and welcome to Electronics by Avin. I will be teaching you the basics of practical electronics step by step. To do this, I will be using the software Tinkercad. Tinkercad is a free online tool for creating 3D models, circuits, and more without any payment required whatsoever. I will be using Tinkercad throughout this video in order to show you the different circuits in a way that will be more meaningful than some circuit diagrams, which I'll cover later. First, you'll need to sign up, or sign in if you already have an account. The sign in button should be on this top corner. Once you've signed in, you will see a list of projects, or if you haven't made any, some basic tutorials in order to understand how to use it more effectively. These tutorials can also be found in the Tutorials tab over here. So as you can see, all of your tutorials right here. Once you're ready to create, you can either click here and select circuits, or if it's your first one, you can go here and click. Give it a minute to load as it'll take some time. Yeah. Don't mind the name, that's an auto-made name. So, now first let's understand the basic components and things that you will be needing for this. Here is an LED. You can change the color if you want. So, for example, yellow. LEDs are very simple components and are used in hundreds of things in your day-to-day life, including the display you're watching this video on. A rule of thumb for most components that are polarized, like this LED, which means that they have a positive and a negative, is that they will usually have a longer positive leg, or anode, than their negative one, or cathode. Here you can see the bent one is positive, while the straight one is negative, as the bent one is slightly longer. However, in real life, it'll be much easier to tell that it's longer. Now, here is a battery. Batteries provide DC current and come in many shapes and sizes. These will be the power for all of your electrical circuits, and their voltage and amperage can differ, so it's best to make sure that it is correct for your purposes. As I said, batteries provide DC current, which means direct current. Direct current only has one positive and one negative, and that cannot change. There is also alternating current, which is used for your sockets and plugs in your house. AC is easier to transfer, but DC can be stored and generated more easily, like for your battery right here. Next up, we have a resistor. Resistors come in many shapes and sizes, with various levels of resistance. The resistance of a resistor is measured in ohms, OHMS, and uses the omega symbol. This is a kilo ohm, so this is 1 ohm. So the resistance value is indicated by all of these different colors on it. So as you can see, when I changed it, this color here changed. So that is because the amount of the multiplier, which is what's used to find the final one here, changes when you go from kilo ohm to mega ohm or just back to ohm. So the colors are your main indicator. So there is a table of values that can be used to figure it out, and I'll briefly show it on screen so that you can, understand. But the easiest way to find one is just searching up resistance color calculator. Any one will work, either 4 band, 5 band, whichever. So this one here which I recommend, you can select the colors shown, like let's say a red, orange, yellow. You'll get your amount in ohms, kilo ohms, mega ohms, and then you have the final band, which is your tolerance. Tolerance just means how much it can go up and down. So if it's brown, that means that it's 1% could be off. So 1% of 230 kilo ohms could be less or it could be more. But if you have a silver one, that could go all the way up to 10%. So it could be 23 kilo ohms lower or 23 kilo ohms higher. So depending on the tolerance, you can have different values. As in real life, not everything is 100% accurate. And finally is a breadboard. So in a breadboard, as you can see these colored ones, it has various rows and columns. Each row, labeled 1 to 30 on this one specifically, is connected to one to another. So for example, see how everything lights up green? All of those are connected. So if you were to plug in one here and had this connected here, then that would be fully connected. So if you see start simulation, it connects together even though directly you cannot see it. I won't be using it in Tinkercad as it can clutter things up. However, in the real world, it is very useful for when you want to test something, but you don't want to go all the way to soldering everything together. Now I'll make a simple circuit. Resistors are going to be used to prevent the LEDs from burning out. So I will be using 370 ohm, and you connect the positive to the positive, negative to the negative. We're going through the resistor for this one. The wires can overlap as long as they're not connected because of the insulating stuff. So if you see, it's lighting up, and and it's lighting up in a way that you can easily see that yes, the circuit is working. However, as you saw when I didn't have the resistor, there's an explosion. This is what we call burning out. This means that while the circuit is working, without a resistor, this can cause long-term damage to the LED, which we call burning out. This burnout isn't necessarily dangerous, but depending on the voltage, it can be. So it's best to keep everything nice and tidy with resistors everywhere. So now that you've understood the basics, I will show a circuit diagram that uses pictures instead of symbols so that you can understand it, and try to make your own so that you can see if you can do it. If needed, you can see the tutorials that I mentioned earlier. Okay, so here is your circuit. I've tried to make it easy, although there is a switch, which you can also use a push button, or you can also look for a toggle switch. I'd recommend using a push button as it's the easiest to work with just each side being connected to one another once you press the button. Once you want to test it, click Start Simulation and test it. If you want some more information, there are some tutorials on this. Pause to have time to finish this. Welcome back. Now that you've attempted your first circuit, I will show you how to make that very same circuit in a new project. Create circuits. So this specific circuit had a bit of a trick to it. So unlike usual, it wasn't using an LED, but instead it was using a light bulb. A light bulb is similar to an LED in that it produces light. However, unlike an LED, it's non-polarized. So if you were to place them both here, place both of these wires here, it's lighting up, But then if you were to stop it and switch this over and then switch this one over, it would still work, making it so that it can work both in both ways. So as for the circuit, there was another bit of a trick to it. So the issue with Tinkercad is that for some reason, the most reliable way to get it to work is to have both sides of the positive and negative going through the button. So if you are to start the simulation, it only works, it also only turns off when you press on it, which is counterintuitive to what you'd usually think. Also, if you were to use a slide switch, I'll show you what would happen. So slide switch, connect one end, put this in the common, and put terminal 2 over here. So now when it goes to when you flick it to terminal 2 side, it activates. If you were to put it on terminal 1, it would be the same except the switch would have to be on the other side. Now that that's done, I'm going to teach you the next important thing to know: circuit diagrams. Circuit diagrams are a mostly standardized method of knowing what all components are used for a specific purpose in a circuit. Some of the diagrams are labeled, but the more complex ones are usually only the symbols, making it vital to know what the symbols mean. I'll briefly show a table on screen for reference that'll tell you exactly what each symbol correlates to. There are some symbols not included, although those are for mainly more complex ones. There are also some that I haven't covered yet, so you can ignore those. If you wish to find a circuit diagram for anything, you can usually just search up the type of circuit. For example, I'll just go for a random simple circuit, and you can go to their images and find everything. So this is the circuit that you just made. Here's your battery. The positive side goes to a switch, which goes to a light bulb, which goes back into the negative. In fact, the one that I'd shown you earlier, this one, it actually has a small version of the circuit shown with symbols over here. For the rest of the segment, I will be using a tool called circuitdiagram.org. It's a free website that you can use in order to easily create circuit diagrams. Let's try making a simple one. Get started, and yeah. It's similar to Tinkercad in that you can drag from this side. However, unlike Tinkercad, it stays on your mouse unless you click one of these. So there are two main types of circuit that you should know of: parallel and series. I'll just show you an example of both. So for an LED, we'll have one LED, two LEDs, and three LEDs. This is in series. And for the parallel, I'll just drop three over here for later use, where I can drag them later on. I'll grab a battery. Whoops. Battery. Here's your battery. Then you can drag it over here. You can also click on it to edit it. So 9 volt. Grab a wire. Grab a switch. So any type of switch in particular, like let's go for a toggle switch. Then grab another wire. and close off this circuit. This is a series circuit. You can also incorporate a resistor, although unlike in parallel, it's less required as you don't need as more LEDs means there's less load. So you can also there's less load on the individual LEDs. So as for a parallel circuit, I'll now show. So we'll grab another battery and a resistor. Grab a push switch or a button. Flip this around. Okay, and now we just connect all of these up with wires. This is a parallel circuit. So the main difference between parallel and series is that if you were to break one of these, like this one broken, now the entire circuit is gone because that one LED, which was connecting the two, means that there is now a break in the circuit and no electricity can flow. However, in a parallel circuit, let's say this LED gets broken. Well, everything is still working because and these ones are still connecting. These two are still connecting, but it's just this one that will no longer work. And therefore that's the one, and that's also the one that's broken. So that's the reason it isn't working. The same resistor will also connect to all of them since it's connected from here. So yeah, that's the parallel and series circuits. Now that I've made this, I will show you both of these in Tinkercad. So I will take this away, remove all of this, and have two, one for each circuit type. Grab the LEDs, connect them all up in a daisy chain, grab a toggle switch, see how all of them turn on simultaneously. As for your parallel circuit, grab a resistor, connect it up, grab a slide switch, and then just kind of copy paste this. I'll even change the colors to make it easier to tell. So now they're all connected. Red on, yellow on, green on. See how they kind of dull when the other is turned on? That's because one is taking more power, so this is taking more current, and yeah. So depending on which one's taking more power, like the red is taking the most since it's closest and is the path of least resistance, there would be less electricity flowing to the yellow. Also, as I showed earlier, if I were to break this one is still supposed to be connected. It's just that wire I'd accidentally connected it to the yellow LED. But in reality, it would be directly connected to the negative. Like there would just be one negative wire and this would be connected to it. So yellow's still not there, but the green LED is still working. Both LEDs are still working. However, if this one was to break, this one ain't going to turn on anytime soon. Now that you understand the basic circuit diagrams, try this one on screen now. Please note that in this circuit there is a specific push button and a specific toggle switch, meaning you must use the correct one for each part. If necessary, you can go back to find the table of symbols. Otherwise, you can pause the video to have time to finish. 3, 2, 1. Now that you've finished, I've gone ahead and created the same circuit that you were supposed to make on this. So as you can see, I even color coded the wires. So the yellow one is the common, the red one connects to this LED, and the green ones connect to this LED here. So if you click start simulation, it disconnects when you press this button, and this one's a toggle. See how it dims slightly? That's because the red takes more of the power. Now, this brings us to the end of the video. Now that you've completed this video, you should be able to understand the basics of practical electronics, but there is still much to go. Keep on learning more about circuits and try using some IC or integrated circuits in order to make better and bigger circuits. Someday, you will be able to make any circuit of your choosing, but for now, you still have much to learn. If you need any clarification, please check the earlier segments or search it up, as there is no guarantee that I will read your comments. This is me, signing off for this video.